So there's one thing I'd like to jump into before we start actually looking at how to create UVs, which is the concept of texel density. So I'm going to come over here to my UV editor. And right now I've got my UV toolkit docked. Yours may not be docked. If you don't see it, you can just go to Tools, Show UV Toolkit. And then if you just kind of drag it over, you can see you'll get this little blue line there that will give you the option to dock it. And that makes life a little bit easier. So texel density, right now I have 3 different cubes, and you can see my grid here. So this cube is 1 unit on all sides, and the units are set in the Windows preferences, so it could either be a centimeter or a meter or an inch or whatever. Doesn't really matter. This would be something that would be dictated by whatever the ultimate destination of the geometry happens to be. So this one is 1/4 of that size. So this is 1, and this is 0.25, and this is 2. And you can see they all have the exact same UV layout here, over here, this little upside down T. And if you go to, in your UV toolkit, to the transform menu, and you scroll down a bit, what you will see here is this little texel density area. So texel density is the number of pixels in your texture per unit of geometry that you have. So a pixel, if anybody is unclear, is it's called it's short for pixel element. So if I zoom in, you can see each one of these little squares is a pixel. And this texture happens to be 2048 by 2048, which means there are 2048 pixels this way, and there are 2048 pixels this way. So this is a texture. And as the texture is applied to the geometry, it becomes a texel. So those are what those terms mean. And what we're going to look at here is this value, this texel density. So if I click on my regular little 1 by 1 by 1 cube here, I can set my map size. This is my output texture to something reasonable. 2048 is not an unusual size there. And then I can select the geometry and press the Get button, and we can see it is 512 texels per unit. So that means that if I had this face on a texture, I have 512 pixels to describe each face approximately. For the cube, it's exactly, but for something where you have like something with a little bit more variation, it might not be perfect, especially if there's a little bit of distortion in your UVs. Distortion being something that we spoke about in the previous tutorial. So with the smaller cube, with the same UV layout and the same map size, I'm actually going to be able to access a much denser count of texels per unit. Again, because the per unit is the world space and the pixels is the texture space. So if I click this, accordingly, we can see now we're getting over 1,000 pixels per unit, because this is much smaller, but the texture size is the same. And alternatively, if I grab the larger cube and I hit Get, we can see that I have just cut it in half. So I went from 512, so that's 512 pixels per face here, and a square. And then for this one, because the texture size stayed the same, but the geometry got larger, I now have fewer pixels to distribute across the surface. So the way that this really comes into play is if you're dealing with environment art. That's where I've seen it most prevalently, although certainly it shows up in other places. And the idea is if you have a whole bunch of different art assets like logs and rocks and whatever, old buildings, and I mean, you name it, anything that you might see in a video game, if something has a very low texel density, it's going to appear very pixelated in the game. Whereas if something has a very high texel density, it's going to look very clean and very crisp and sharp. So you want to avoid having big variations in the texel density on objects that are sitting right next to each other. So typically what they'll do is they'll say, okay, for all of the environment assets in the game, we are going to make sure that everything has a texel density range of 200 to 225 or something. And then what you do is you just try to make sure that based on your UV layout, you are nailing the appropriate texel density for whatever the object happens to be. So this is something that we're going to pay attention to, and it's mostly going to be in the context of looking at different kinds of layouts, like different ways that you can lay out your UVs to get a little bit more. The goal is usually to get more. You almost always want to push this, because the sharper the texture, the more dense the texels, the clearer the texture looks, and the better the final result is. So, and there's a cost, right? Like a 2048 by 2048 is 1/4 the price of a 4096 and 4 times the price of a 1024. So it's very important from a perspective of performance. So you always want to kind of pay attention to that. And before we jump in, I just wanted to go and clear up what this is and kind of how it works and what's going on under the hood there. So another thing that I want to talk about, I'm going to go ahead and get rid of my cubes here, and we'll hop over to our dragon friend. So we can actually just do a quick get on this, so we can see that it's 240. Again, this is totally arbitrary. It has to do with how big the geometry is. So if I make it bigger, like that number is going to go down, and if I make it smaller, that number is going to go up, because there are relatively more texels per polygon, and that's what drives that value. So we can take a look now at the idea of texture sets. So you can have multiple texture layouts, multiple UV layouts, I should say, on a single piece of geometry. And there are lots of reasons why you might want to do this. A very, very common one is for supporting what are called light maps. So you can see in this geometry, I only have one side here. And let me go ahead and just hit the 6 key. So if I double click this UV shell and I move it, we can see there is actually another UV shell underneath it. So these are called stacked UVs, and it's a way that you can optimize your UV layouts. So if this thing is the same on both sides, then this is a really, really smart thing to do, because you can go ahead and basically significantly increase your available texel density by stacking things that are going to be the same. So the same thing here on the foot. The front feet are the same, so they're stacked. The back feet are the same. For this kind of an asset that's kind of simple, this is really common, where you're trying to use the lowest possible texture size that you can without losing your visual quality. But if like this was some super high fidelity asset that you might see in some first-person shooter or something, then you would want to make sure that the wrinkles on one shoulder were not the same as the wrinkles on the other shoulder. Otherwise, it looks like you're cutting corners, and people can pick up on that. So what we're going to do here is I'm going to talk very briefly about the light map thing. So in a game engine, imagine this is not something that would be animated. If this is just like a statue of a dragon, in the game engine, a designer might come along and put a light over here. So the light is shining on this side of the dragon and not on this side. So to calculate in real time the behavior of the light on the dragon is pretty expensive. So what you can do is you can actually bake the lighting information into the texture so that it basically gets multiplied over the original texture. So like if this was the original one, there's going to be a black and white image that just shows up as white on this side of the dragon and black on this side because the light is over here. And then you just sort of multiply those two images together and you get what's called baked in lighting. So if you move the light in the game, it wouldn't change how the dragon statue appeared. But the problem is if you've got your texture or your UV shells stacked, then whatever you do on one is going to show up on the other. So you would need to have a unique UV layout for your light maps. That it can Unreal, for instance, and probably Unity as well, two very common game engines, can generate their own light maps. But this is how you would do the UV side if you wanted to. So we're going to go to UV sets. I'm going to open up the UV set editor, and we will just click new here. And just to keep things organized, I'm going to go ahead and name this UV set light map. And you can see when I do, I don't get any UVs here at all. So I would like to keep my UV islands here, like my UVs that I've already created. So actually, instead of making a new one, well, let me see if I can. There's probably a way to move the UVs over fairly easily, but just to save us from having to watch that, I'm just going to hit copy instead. And so now you can see as I toggle between the two, these are totally being preserved. And now I'm just going to rename this as light map. And now that they're over here, I can do an auto layout. So that's where Maya is going to make some good decisions about how to lay this stuff out. And that's going to be down here in Arrange in Layout. And we'll just go ahead and click Layout. And you can see it'll maintain all of my shells, but now everything is unique. So that, well, by unique, I mean nothing is stacked. And there are some settings here that we'd want to tweak or whatever, but this would be a perfectly fine light map UV channel that would live in an additional UV set. So here's the one that we use for texturing, where we have our optimal Texel density by stacking UV shells where possible. And then we have our light map UVs, where everything is unique, and it would be able to support different lighting information for where lights happen to be in this, where this is a static asset in a game. So, okay, that is a very quick little rundown of a couple of things to keep in mind as we move forward with UVs that I'll probably be referencing as we go. And yeah, so let's go ahead and take a look at the process for creating UVs.